All right, so this is going to be a video on the law of cosines, and just like the law of sines, it's pretty straightforward in terms of, there's not a lot. We're not going to go into a whole lot of conceptuals about like where it comes from and all that, but you will see that it's basically almost whatever formula it is. You kind of just make sure you have the right sides and angles all matched up, and you just plug it in. That's about it. But what law? We'll see. So law of cosine, a couple things that you'll notice that um, now I don't want you to think about it as like whatever angle was C or what, like it has to be these particular letters, right? Like there's all you should see is that these are three sides, right? So ABC are triangle sides, and these two, the outside are a pair. So those are the pair that's a pair that you have whether you're solving for a side or you're solving for an angle. It doesn't really matter. But the point is that the outside is going to match, um, while the inside AB and AB are going to be kind of back to back. So C is a an angle measured in degrees. So for this section, just like the law of sines, make sure your calculator is in degree mode, not in radian. So this it looks very, very similar to the Pythagorean theorem, of course, because you see the a squared plus b squared Pythagorean theorem equals to c squared, but then there's this extra piece here. Um, but that's perfectly fine because if you think about it, if you have cosine of 90 here, like if this was a right angle, if this was cosine of 90, right, then this whole term disappears, right? Because cosine of 90 or cosine of pi over 2 is 0. So this is basically the Pythagorean theorem except for non-right triangle. So when should we use the law of cosines instead of the Pythagorean theorem? I know I'm writing kind of sloppy here. When we don't have a right triangle. Oops. So let's take a look. Now, the main um, times, I guess, you'll use the law of cosine is if you're given a side angle and the side kind of back to back to back or side, side, side of three sides. Um, those are the times normally you'll get it because you'll notice that here, like I don't have a an angle side pair that I can use for law of sines, right? The angle here I'm missing, which is normally going to match up with my 400 here. The angle here is missing for 375. Well, I don't have the side length here for the 35 degrees. So this is the time you're like, okay, law of sines is not going to work. Let me try law of cosines, right? So, and again, I'm going to go ahead and solve for the side length b, right? But again, remember that even though it's c squared equals a squared plus b squared minus 2ab cosine c, this just means that this side and this angle should be the matching pair. So in this case, I'm going to write it out as b squared is equal to a squared plus b squared, or a squared plus c squared minus 2ac cosine of the angle b, right? So that way, if I take the square root of everything here, I will be able to solve for b. So b is equal to the square root of 400 quantity squared plus 375 quantity squared. I'm going to extend this out just a little bit. Minus 2 times 400. 375. Looks like I didn't extend it quite enough here. Cosine of 35 degrees. So I'm actually gonna put it all into the calculator all at once. Notice that you have three different terms here, right? You have a 400 squared, you have a 375 squared, and you have this huge thing that's another term. But they're all being multiplied or squared that you don't really have to worry about putting extra parentheses in there or anything. So I'm going to show you how I'm going to put it in. So in Desmos, or if you have a graphing calculator, it doesn't really matter. 400 is my first term, squared, plus 375 squared. And then I have minus 2, whoops, should still be inside the square root here, minus 2 times 400 times 375 cosine of, what was it, 35 degrees? 35 degrees. And I have my solution here of 243 points. Does it tell us the nearest 100? So B is equal to 234.26. Now, they give us length, so make sure to have units in there. And that's it. Okay, but I think the practice here is really trying to make sure you know, okay, what am I solving for? Am I solving for an angle? Am I solving for a side? And if I'm solving for a side, like what do I have? What do I not have? So on and so forth. Okay, now this time they want us to find an angle measurement. We want to find A. Now this is a little bit trickier. I do want to make sure you write it out slowly to know what you're doing here. Notice that we want to solve for A, meaning we want at the end here, we want cosine A. So A squared is going to be on the other side. So I have A squared is equal to B squared plus C squared minus 2BC cosine A. Now I do want to solve for cosine, I'm sorry, solve for A first. So I'm actually going to go ahead and leave everything in terms of their variables and isolate the A first. So I'm going to subtract B squared and C squared. So A squared minus B squared minus C squared is equal to all this, 2BC cosine of A. Then I'm going to divide both sides by this negative 2BC. Just trying to isolate my A value here. Now, I don't suggest this. You could substitute all your numbers in here and then solve for some number. That's fine, but then just be careful. I would not round it because we want to take the inverse cosine in order to actually get a value, right? So inverse cosine of whatever this is, A squared minus B squared minus C squared all over negative 2BC. So I personally would leave the number plugging all the way to here so that I have 27 squared minus 19 squared minus 23 squared. Although, yeah, actually, that's right. All over minus negative 2 times 19 times 23. So I would put this all into the calculator at once. So that's going to look like, hopefully I can do this. Does this count as the, it might not actually. Let me actually just take the actual function here, inverse. It might, I don't know. I don't know how Desmos works sometimes. But what I do have is 27 quantity squared minus 19 squared minus 23. 23 squared, and close my parentheses, divided by negative 2 times 19 times 23. My angle measurement that I do have is going to be 79.38. And of course, it's an angle measurement, so make sure you have the degree symbol. Okay, so again, let's just practice a couple more. Marker A and marker B are 4 miles apart, so it doesn't really matter how you want to draw this out. Okay, this is A, this is B, 4 miles. And Marvin walks 1.8, so we know he's from A, and he walks 1.8 miles and realizes he's 6 degrees off course. So I'm going to draw this obviously not how it's supposed to be, right? This is obviously more than 6 degrees, but just to kind of show that this is 6 degrees and it's easier for me to write it in, I'm going to go ahead and make it a little bit longer than it's supposed to be. All right, so we want to find what this value is going to be. So again, this is angle, I'm sorry, this is side angle side. You'll see that again, I'm missing any sort of pairs that I have, right? So clearly I would need to use the law of cosine. So in this case, it doesn't matter what you use. I use x here. I guess technically it should be a, not a huge deal. A squared is equal to b squared plus c squared minus 2bc cosine a. All right, again, I'm taking the square root on both sides just so I can solve for a first. So square root, b is 1.8, quantity squared, c is 4 squared minus 2 times 1.8, 4 cosine of 6 degrees. Okay, again, just make sure you put it in nice and slow because it can get a little bit tricky with the number of things you're putting into your calculator all at once here. Square root plus 4 squared minus 2 times 1.8 times 4 cosine of 6. Sure. Yeah, this all looks good. So 2.22. 2.22 miles. Not too shabby on that one. Geologists studying an interesting hill and the cliff pattern she found on the beach. Notice the base of the hill on level ground is 48 meters long. The hill goes up towards the edge, measures 56. Other side is 30. The diagram shows and find the angle between the ground and the hill. So we want this angle measurement right here. This is what I'm saying. Like it doesn't really matter how you name these. I'm gonna just call this A, B, C. Just kind of help guide myself here. But if I want angle A, that means I need to have 30 on the other side, or at least a squared as a symbol that I have minus 2bc cosine of angle A. Now I'm going to again solve for A first. If you follow the same thing that we did earlier, I'm going to get A squared minus B squared minus C squared all over negative 2 BC is equal to the measurement, of angle A. Now, if you're not sure how I got this, again, you'll see it here, right? All I did was subtract the B squared, subtract the C squared, divide the whole thing by the negative 2BC, and then in the end, I have to take the inverse of whatever number that I found inside. So A is 30 squared minus B is 40, 56 all over negative 2 times 40 times 56. Now, for those of you that are looking at kind of like trying to estimating the numbers and stuff like that, you will notice that 30 squared minus 40 squared minus 56 squared is some negative number. But because I'm dividing by a negative number, inverse cosine works out fine. So let's go ahead and do that again. Inverse, let's see if this actually works. Inverse cosine. I don't know if this will. Okay. I don't know why I did that. 30, 40, 56. 30, 40, 56. That's divided by negative 2 times 30 times 56. Undefined. Did I do something wrong? Wonder if it's this cosine. Let's take a look. Oh, it's not that. Oh, 40, not 30. There we go. 31.10. I was wondering what's going on with that value. All right, so I'll do a couple more, just kind of again help set it up and stuff like that. Um, but I'm probably going to go a little bit faster. Here, although I'm solving for a side, there's not much to be done here. A squared plus B squared minus 2AB cosine of C. Again, C then has to equal to the square root of 29 squared plus 13 squared minus 2 times 29, 13 cosine of 41. Now you do notice that I'm not showing a whole lot of like steps and stuff like that, but I would love to. I would like to see what you're using, how you're setting up your equation, right? I'm writing out, okay, I'm solving for C, so that's why C squared is first, right? And all I did was take the square root of both sides, substitute in my numbers. Of course, the remaining is all up to how I put it into the calculator. So I don't. I definitely would like to see um, you show your work in this manner at the very least. Cosine of 41, 41. So I have 20.999. Now, this doesn't give us any units this time, but I'll just write units, whatever the units may be. I want to find the measurement angle A, which is right here. Again, this when you're solving for an angle, this is where you have to be a little bit careful because I need to look for, okay, the angle is A, so A squared has to be on the other side. All right, so it's 23 squared, or let me just write it out in symbols first. So I should have A squared is equal to B squared plus C squared minus 2BC cosine of A, right? Again, the outside should match. So if I am solving for the angle A, I should have A squared minus B squared minus C squared all over -2 times BC. So now I'm going to put in the numbers. A is 23 squared minus B is 25. Not that really matters, but that's okay. -2 times 25 times 14. So putting all this in the calculator, I should get 23, 25, 14, 23, 25, 14, -2 times 23 times, oh, no, 25 times 14. 5.346. Make sure everything looks okay here. 23, 25, 24. Yeah, it looks good to me. All right. Okay. I think these are pretty much the same thing. So I think I'm going to skip these because it's you just look for the sides and that's about it. So I'm not going to, or, angle or whatever. I just set it up over and over again. I'll jump down to some of these word problems just because they're a little bit different. This one I don't think we can do. Yeah, this one's not possible. I don't know why that one's there. Actually, you know what? That one's also, this one I think is actually a law of sine. So, all right, maybe I'll just do these two and then we'll call this video Dunzos for this one. We want to find BC. That's side A here. So A squared is equal to B squared plus C squared minus 2 times B and C cosine of A. So A is equal to the square root of B, which is 17 squared plus 28 squared minus 2 times 17, 28 cosine of 91. All right, so again, this is mostly just calculator work here. Square root 17, 28. 17 squared plus 28 squared minus 2 times 17 times 28 cosine of what, 91, I believe? Yeah, so 33.009. And again, no units, so we'll just write units, kind of a placeholder. The last one that we'll do, again, we want to find angle A, right? So that means 14 should be on the other side. So just be careful here. A squared is equal to B squared plus C squared minus 2 BC cosine of A. So again, showing all that would give you A squared minus B squared minus C squared all over -2 BC. That's equal to angle A. So if I put in all my numbers here, A squared is 14, B is 9, and I have 6 for C, all over -2 times 9 times 6. That should give me angle A. 1496 all over -2 times 9 times 6 So 137.011. All right, I think that's about it. I hope that makes sense. Again, feel free to stop by for any questions. Thank you.